Hi everyone, welcome back. We are continuing with 10.1 notes, but we are on day 2. So in this first problem, we are given that the measure of angle O is 1.4 radians, and we know that the radius of the circle is 6. I am looking to find the shaded region, so I just want to know this region right there, the area of that. So how I can do this is I have a sector. So this whole part would be my sector. And then I have a triangle as well. So I can just find the area of the sector and then subtract out the area of the triangle. So I would have area of sector minus the area of the triangle. So if we recall, the area of a sector, we find that by 1/2 radius squared times theta. Okay, it is important that theta is in radians and not degrees. What is given to us is radians, so we are good to go. So I have 1/2 6 squared times 1.4. If we substitute that into our calculator, we end up having 25.2 centimeters squared. Okay. Now, from yesterday's notes, the area of a triangle, we can find that by 1/2 side A times B times sine of theta. Okay, now again, it has to be side angle side, but if you look at the triangle, it is side angle side. So let's go ahead and substitute in. So we have 1/2 6 times sine of 1.4. When you type this into your calculator, make sure that you are in radians, and we end up with 17.74 centimeters squared. So now we know the area of the sector and the area of the triangle. So to find the shaded region, we are just going to subtract the two. So 25.2 minus 17.74, and we end up with the area of the shaded region being 7.46 centimeters squared. Okay, number 2, from a point on ground level, you measure the angle of elevation to the top of a mountain to be 38 degrees. Then you walk 200 meters further away from the mountain and find that the angle of elevation is now 20 degrees. Find the height of the mountain, and then we're going to round our answer to the nearest meter. Okay, so to do this problem, we're going to have to sketch something out. So here is my triangle. Okay, and my mountain is over here. So we are standing at that point, and the angle of elevation is 38 degrees. Okay, but it's saying we are now walking 200 meters further away. So I'm going an additional 200 meters. And now that angle of elevation to the top of the mountain is now 20 degrees. Okay, and we do have a right angle. We've got a right triangle over there. So we want to find out how high the mountain is. So I am trying to find this height. Okay. So to set this up, we have two angles. And if we want to call this y and this x, so our height would be x, and then the length of the smaller triangle is y. So looking at our 38-degree angle, we have our opposite and our adjacent sides. So we can set up tangent equation. So I can say tangent of 38 degrees is equal to x over y. Okay. Now if we look at our 20-degree angle, we also have tangent. So for that one, I can have tangent 20 degrees is equal to x, but this time the whole length is going to be y plus 200. That's the adjacent side. So we have a system of equations here. So I'm going to try to solve for y using my first tangent equation. So I would have y times tangent 38 degrees is equal to x. So then y is equal to x divided by tangent of 38 degrees. Okay, so now I can take what y equals, so x over tangent of 38, and substitute that into our second equation. So when I do that, I have tangent 20 degrees is equal to x over tangent 38 degrees plus 200. Okay, so the tricky part here is just doing the algebra that's involved. So what I'm going to do is multiply both sides by tangent of 38 degrees. So I'm going to multiply the numerator and denominator by tangent 38. So I have tangent 20 degrees is equal to x times tangent 38 degrees all over x plus 200 tangent 38 degrees. Okay, now I'm just going to cross multiply. So when I do that, I'm going to have to distribute. So if I have this over 1, so I have to distribute the tangent of 20 to both x and to 200 tangent 38. So when we do that, we end up having x tangent 20 degrees plus 200 tangent 38 degrees times tangent 20 degrees, and that is equal to x tangent 38 degrees. Okay, so from this step, if we notice, we have x tangent of 20, then x tangent of 38. Well, I'm trying to solve for x, since that's my mountain height, so I'm going to move that all over to the same side of the equation. So I've got 200 tangent 38 degrees times tangent 20 degrees is equal to x times tangent 38 degrees minus x times tangent 20 degrees. Okay, I'm just going to move up so I have more room. I'm going to rewrite this and I'm going to factor out the x. So I'm left with tangent 38 minus tangent 20. Okay, so if you notice, all we have to do is divide both sides by tangent 38 degrees minus tangent of 20 degrees, and we have x by itself. So 200 tangent 38 degrees, tangent 20 degrees, divided by tangent 38 degrees minus tangent 20 degrees is equal to x. So we can type all of that into our calculators. We just need to make sure that we are in degrees and not radians. And we are rounding to the nearest meter. So when we substitute all of this in, we end up that x is approximately 136 meters. So the mountain is about 136 meters high. Okay, number 3, the arc is part of the unit circle and theta is in degrees. We want to find the following angles in terms of theta. So we want to find angle BOA and angle AOB, and then we want to express the lengths AO and AP in terms of sine and cosine. Okay, so let's first take a look at what we are given. So we know that we do have a right angle right here. We have several right angles. So because of supplementary angles, we have a whole bunch of right angles. Okay, so we first are taking a look at angle BOA. Right? Well, if we know that theta is down here, okay, and I have a right angle, then we'd have to be able to conclude that angle BOA is just going to be 90 minus theta. Okay, then we can take a look at our next angle, which is OAB. And together, BOA and OAB have to equal 90 degrees since angle B is a right angle. Okay, so since we already know that BOA is going to be 90 minus theta, then angle OAB is just equal to theta. Okay, so we can also take a look at this purple triangle and conclude similar things. So this angle right here would have to be 90 minus theta. And then I have a right angle, so angle P must just be theta as well. So next, it's asking us to find the lengths OA or AO and AP in terms of sine and cosine. So let's first take a look at AO. So to complete this problem, I'm going to resketch this triangle. So I've got A, I have O, I have P. And at angle A, we have a right angle. And angle P is theta. Okay, so I am trying to look for AO. Well, I also know that the arc is part of the unit circle. That's important because I know that the hypotenuse here is going to be 1. This whole length is 1. So if we're taking a look at theta and I want to know what AO is, I'm going to have the opposite side and the hypotenuse. So I can have this opposite and hypotenuse, that's always sine. So sine of theta is equal to AO over 1. So I can just say that AO is going to be equal to sine of theta. Okay, now the last side that we're looking for, I'll highlight in green, is AP. Okay, let's call that Y. So again, if we're looking at theta, now I have the adjacent side and the hypotenuse. So I have cosine of theta is equal to AP over 1. So AP is equal to cosine theta. Okay, and number 4, we are told that AB is 8 inches. So we've got this entire side is going to be 8 inches. Then we are trying to express x as a function of theta. Okay, so there's a couple things that we need to do with this problem. First, let's go ahead and just extend this line down. Okay, and if you recall back from your geometry, if we have two lines that are perpendicular to the same line, then those two lines are going to be parallel. So we have this line right here is going to be parallel with our bottom line. Okay, so that would make AB being our transversal. Okay, and if you remember when you have parallel lines, we also have corresponding angles are congruent. So if we know that we have theta down here, then this angle by P is also going to be theta. Okay? So let's just take a look at our top triangle now. So we've got this triangle up here. Okay? So what we can say, if we're looking at theta and we want to have this side, let's call that X. Well, we already have an X, so let's maybe call that Y. Okay, so we have the adjacent side and the hypotenuse. Okay, so I'm going to write this as cosine of theta is equal to the adjacent side, well, that was X, over AP. Okay, so let's try to solve for AP. So if we do that, I'm just going to switch my cosine theta and my AP. So I've got AP is equal to X over cosine theta. And just using what we know about trig, I can also just rewrite that as being x secant theta. Okay, so let's repeat this process using our second triangle, so the one down below. So again, if I use PB as a side, I now have the opposite side, which is 4, and then the hypotenuse. So opposite and hypotenuse goes with sine. So I have sine of theta is equal to 4 over PB. Okay, so again, we're going to solve for PB, so I'm just going to switch my sine in PB. So I have 4 over sine theta, which again, just using our trig identities, and we can rewrite this as 4 cosecant theta. Okay, so why I wanted to get AP and PB solved for is because we know that together that equals 8. So what I'm going to do is have x secant theta plus 4 cosecant theta and say that that is equal to 8. Okay, now I'm trying to solve for x, so I'm going to subtract my 4 cosecant theta over. So I have x secant theta is equal to 8 minus 4 cosecant theta. Now let's just go ahead and divide both sides by secant theta. Okay, and we were just looking to express x as a function of theta, and we did that. So our final answer is just going to be x is equal to 8 minus 4 cosecant theta divided by secant theta. Okay, and our last problem, number 5. So we want to let r equal the radius of the moon. Okay, so I'm going to label this and that. And we should know that PT, is tangent. Okay. So we want to show that r is equal to sine of theta divided by 1 minus sine theta times ps. All right, so we also know that pm can be written as ps plus the radius. Okay, and we've got theta, it's small, but we've got theta over here for angle SPT. Okay, so if we look at theta, then we have our opposite side and we have our hypotenuse. So that goes with sine. So I am going to write down that sine of theta is equal to the opposite side r over my hypotenuse, which is ps plus r. So I'm just going to manipulate this to try to equal what we're trying to show. So first, let's just multiply both sides by ps plus r. So I'm going to distribute. So I have ps sine theta plus r sine theta is equal to r. Okay, now I have an r and an r, so I'm going to get that all to the same side. So I've got ps times sine theta is equal to r minus r sine theta, and then we can factor out an r. So I have 1 minus sine theta. Now if I just divide both sides by 1 minus sine theta, I am done. So I've got ps times sine theta divided by 1 minus sine theta is equal to r. And that is what we are trying to prove. Okay. Now in part B, it says if PS is equal to 238,857 miles and theta is equal to 0.257 degrees, we want to find r to the nearest 10 miles. Okay, so we just have to substitute into what we just found r to be equal to. So I have got 238,857 times sine 0.257 degrees. Make sure your calculator is in degrees. All over 1 minus sine 0.257 degrees. If we type that into our calculator and round to the nearest 10 miles, we are going to end up with R equaling 1,080 miles.